All right, I had some requests to review some nuclear equation writing, so that's what we're going to do here. Okay, I've got some samples we're going to go through, and hopefully we can answer some questions and get you a little more practice. Okay, we're starting off with uranium-238, which is undergoing alpha decay and produces 2 gamma rays. Now we know it has to produce something else because the law of conservation of mass must be applied in all chemical and nuclear reactions. So we're looking for actually 3 products to this equation. Let's go ahead and start. We put the mass number on top, 238. And on a periodic table, we see that uranium is element number 92. Okay, make sure you're using a periodic table that has the element names on it so that you can confirm you're using the correct element. All right, it undergoes alpha decay, so that tells me that the alpha particle is going to come after the arrow. So an alpha is a 4 on top, a 2 on bottom, and a helium nucleus. And also that 2 gamma rays are made. Okay, so I have a choice here. I can write 2 separate gamma rays, kind of like this. Or if I want to make life just a little bit easier, I can clump those guys together since they are the same and just put a big 2 out in front and know that that applies to the gamma rays. Either way is perfectly fine. Either way you want to write that. But I do know that my masses don't add up, so there is something else that I need to make here. Now, this is basically turning into a addition problem. We are going to look at this arrow and think of it as an equal sign. So let's go ahead and look at the top numbers first. Okay, I've got 238 equals 4 plus 0 plus 0 and something else. So 238 would equal 4 plus 234. So that's going to be my top number. I'm going to do the same thing for the bottom number. Okay, we're going to turn it into an addition problem. 92 is equal to 2 plus 0 plus 0 plus something we don't know. And that would have to be 90. So 90 is the bottom number. And this is the one that we go and look at the periodic table to see what element is element number 90. That's going to be thorium, which is TH. So now we've got our complete nuclear equation. Let's go ahead and keep practicing. All right, neon 22 nucleus is formed. Now this stands out. They're telling us that this is a product, meaning it's going to come after that arrow. Okay, neon 22. So 22 is the top number. Neon is the element, and on the periodic table, neon is element number 10. Okay, so neon is formed when an element that we don't know undergoes beta decay. Decay is talking about the beta particle and telling us that beta is going to come after the arrow also. So we need to figure out what comes before the arrow. And again, we're going to look at this arrow as an equal sign, and we're going to do our top numbers first. 22 plus 0 gives me 22 again. On the bottom, 10 plus -1, be careful with those negatives. 10 plus -1 is 9. Element number 9 on the periodic table is fluorine. And now we've got our completed nuclear equation. All right, let's try a couple more. Here we've got samarium 146. Now, some of these might take a little while to find on the periodic table, but that's why I want you to get a periodic table that has the names of the elements written as well. Sometimes the symbols don't match what you think they should be because they're based on Latin names. Samarium 146 is produced. So this is another one where they are telling us that this element, samarium 146, is a product, meaning it comes after the arrow. Okay? The mass number, the top number is 146. And on the periodic table, samarium is element number 62. It says this is produced when an element undergoes alpha decay. So alpha is also after the arrow. An alpha particle has a 4 on top and a 2 on the bottom. It's a helium nucleus. So now we need to figure out what comes before the arrow. So we're going to change that arrow into a plus sign and go ahead and do a little math. 146 plus 4 is 150. Okay, 150. And then 62 plus 2 is 64. Element number 64 on the periodic table is gadolinium. All right, we have completed our nuclear equation. Okay, here we've got one that tells us about the beta decay first. The beta decay of dysprosium 165 creates a new element. Beta decay, this is telling me that the beta particle is coming after the arrow. It also implies that this is the element, dysprosium 165, is decaying. So this is what I'm starting with. And it's going to break into the beta particle and a new element. So that's how I'm going to go ahead and set this up. We've got 165 as our mass number. Dysprosium is our element, and it is element number 66 on the periodic table. It is breaking down or decaying into a beta particle and a new element. So we're going to think of our arrow as an equal sign. 165 is equal to 0 plus 165 again. 66 is equal to negative 1 plus 67. Be careful with those negative ones, okay? Element number 67 is holmium on the periodic table. And there we go. Remember that the top numbers need to add up to the same total on both sides of that equal sign, and the same is true for the bottom numbers. Let's do one more. Now this one has a little bit different wording. What atom produces scandium-47 when it goes through a beta decay? Okay, so we know that our scandium-47 is produced. So that's going to come after the arrow. And we've got beta decay here. So that's telling us that the beta comes after the arrow as well. We need to figure out what atom we are starting with. So I'm going to go ahead and put scandium-47 after my arrow, as well as my beta particle. I need to figure out what I started with. So here we go. Our arrow is our equal sign. 47 plus 0 is 47 again. 21 plus negative 1 is 20. Element 20 is calcium. And there we go. All right, hopefully this has helped. Just another walkthrough to help you practice. Okay, as always, if you have questions or need further help, feel free to shoot me an email. And good luck on your test tomorrow.